Figure 3 shows part of the curve C with parametric equations. X equals tan theta, y equals sine theta for theta between 0 and pi over 2, touching 0. The point P lies on C and has coordinates root 3 over 2. Here. So, find the value of theta at the point P. The line L is a normal to C at P. The normal cuts the x-axis at the point Q. Show that Q has coordinates k root 3 naught, giving the value of the constant k. The finite shaded region S, shown in figure 3, is bounded by the curve C, the line x equals root 3 and the x-axis. This shaded region is rotated 2 pi radians through 2 pi radians about the x-axis to form a solid of revolution. Find the solid of revolution, giving your answer in the form p pi root 3 plus q pi squared, where p and q are constants. So let's have a look at this. Then I've got the summary here. So find theta at P. So when is tan theta going to be root 3? Isn't that 60 degrees, isn't it? So answer, so A, I'll just put it here. Theta is equal to 60 degrees. Tan 60 is root 3 and sine 60 is root 3 over 2. So that's fine. That's part A. L is normal to C at P and cuts the x-axis at Q. Show that the point Q is k root 3 naught and find k. So we got a normal at P when theta is 60, and there's our parametric equations, tan and sine. So x, this is part B now, x equals tan theta, y equals sine theta. We know at P, theta is equal to 60 degrees, so P has coordinates at root 3 and root 3 over 2, wasn't it? So now we need to get the normal, so let's get dy dx. So dx d theta, so here dx d theta first, tan differentiates to sec squared theta, dy d theta is equal to sine differentiates to cosine. So dy dx then is equal to dy d theta divided by dx d theta, that would be cosine theta, divided by sec squared, which is 1 over cosine squared theta. So the cosine can all move up to the top and we're left with cosine cubed of theta. Cos 60 is a half, so this is a half cubed, which is 1 over 8. So the normal gradient at P must equal minus 8 negative steep, which is what is depicted on the sketch. So it looks like we're on the right track. So the normal gradient is minus 8. So the equation of the line then through P is y minus root 3 over 2 is equal to m minus 8 x minus the value here, root 3. So here's the equation of the line. This is the line L. Now the line cuts the x-axis, so y equals 0. It cuts the x-axis, gives. So that would then be x minus root 3 in a bracket. Now I'm going to, the y is 0, so the minus 8 comes underneath this minus root 3 over 2. And I'm reading it from right to left, so it's root 3 over 16, isn't it? So therefore x is equal to, move that root 3 over, so that would be root 3 plus root 3 over 16, which equals, that's 16 over 16 root 3 plus 1 more, 17 root 3 over 16. So there's the x coordinate then. So I think that's part B. K root 3, find k. So k is equal to 17 over 16. So that's part B done. Now we need to turn our attention to part C. Here S is rotated 360 about OX. So let's look at the diagram. Remind ourselves that when we rotate this around, we're going to generate a cylinder. This cylinder is going to look like this, isn't it? All these cylinder slices. The volume here of this tiny cylinder will be pi r squared, the radius, which is pi y squared, times the thickness, which is delta x. So we need to sum all these cylinders between 0 and root 3. So the volume then, which we can call V, the volume is equal to the integral of pi y squared dx, and we're going from 0 on the x value to root 3, wasn't it? Just double check that again. Yeah, these slices get added up between 0 and root 3, don't they? Y is equal to sine theta. Okay, so y squared dx. So we're going to have to replace what dx d theta we need, don't we? So x equals tan theta. So dx d theta is equal to sec squared theta. So we can replace dx by theta now. Y squared is equal to, y is equal to sine theta, wasn't it? From the above. So let's put it in then and see what we get. So this is equal to pi y squared. Now y squared is sine squared times dx, which is sec squared d theta, when we move the d theta up. So we get that when x is 0, theta is 0, isn't it? And when x is root 3, theta will be pi over 3, 60 degrees. Tan 60 is root 3. So there's our integral then. This is cos squared, so in essence we've got pi, the integral of sine squared over cosine squared, which is tan squared, d theta. Okay, so that equals then between 0 and pi over 3. So that equals then tan squared is 1 minus, tan squared plus 1 is sec squared, so this will be pi. The integral of sec squared theta minus 1, isn't it? D theta using the trig identity. Tan squared plus 1 is sec squared, so tan squared is sec squared minus 1 between 0 and pi over 3. So this is equal to then, the integral of sec squared is tan. The integral of minus 1 is just minus theta. And we now want to evaluate that between pi over 3 and 0. So this is equal to put pi over 3 in. Tan pi over 3 is root 3 minus pi over 3 is the top value. And the bottom value, put 0 in, tan 0 is 0 minus 0. So we've got root 3 minus pi over 3. And it said express it in the form p pi root 3 plus q pi squared. So there was a pi in front here, wasn't there? So that helps to remember that that should be there, that should be there, and this is pi squared. So that's correct. The answer has helped us get the right answer. Find volume in the form p pi root 3 plus q pi root squared. So p equals 1 and q equals minus 1/3 in the above. Q pi squared, wasn't it? Minus q pi plus q pi squared. So that's why the minus is taken there.